So let us go for integrated rate equations, right? We know that we have two types of rate equations. Let us write this reaction. Reactants gives products. So this is a reaction. We can write the rate of the reaction as a differential rate equation. That is, let us write as differential rate equation. Differential rate equation. This can be written as minus dr by dt, right? Change in concentration with respect to time. And as per rate law, according to rate law, the rate of the reaction can be written as rate constant into concentration of the reactant raised to with respect to its order. N is the order of the reaction. Okay, so these are the two types of expression of rate of the reaction. One is with respect to differential rate equation, another one is with respect to rate law. So here N is nothing but the order of the reaction. N is nothing but order of the reaction. So this is also rate equation with respect to differentiation, differential rate equation. This is also rate equation with respect to rate law. So what we are going to combine these two rate equations and we are going to make integrated rate equations, right? Integrated rate equations. Got it? Okay. So let us go for a zero order reaction first. For a zero order reaction. Zero order reaction. Right? Let us consider the reactant gives products. So the rate of the reaction as per the differential rate of the reaction, that is minus dr by dt. Right? Then with respect to with respect to rate law, that is equal to rate constant into concentration of the reactant with respect to its order. So let us consider this as equation number 1, this as equation number 2. We are going to equate these two, right? So let me write minus dr by dt, that is equal to k into concentration of the reactant with respect to its order. Here it is zero order reaction, so that I am writing 0 here. Anything to the power of 0 is nothing but 1. So this can be written as minus dr by dt is equal to k. This equation can be written as dr concentration, that is equal to minus of k dt. Am I right? This equation can be written like this. Now let us integrate on both sides. Integrating on both sides at this stage. That is integration of dr, that is equal to minus constant, let us take out, integration of dt. So integration and differentiation get cancelled each other. So we can write as r is equal to minus kt plus I. I is nothing but integration constant. Somewhere it has been written as C. Equation we can get. This is I is called as the integration constant. Right? Integration constant. I is called as the integration constant. Okay. Now, at time t is equal to 0. At time t is equal to 0, the concentration of reactant R, that is nothing but it is the initial concentration R naught. That is the initial concentration R naught. Right? This can be written as R naught. Right? Substitute this in this equation. Right? Substitute this in this equation. So this equation can be written as R is equal to R naught. So let me write R naught in the place of R. That is equal to minus K into 0 plus I. Right? So we can get R naught, that is equal to I. R naught, that is equal to I. So substitute the value of I in the place of R. Substituting this in this reaction, here in this reaction. So R is equal to minus KT plus R naught. R is equal to minus Kt plus R naught. So this is the equation which looks like y is equal to mx plus c. Right? This is the equation of straight line. Right? This is the equation of straight line. Now, what is y-axis here? That is R, concentration of the reactant. What is x-axis here? That is time here with respect to time. This is slope, m is slope. What is slope here? That is equal to minus k. Right? Slope is equal to minus k. And what is the intercept here? C is intercept here. C is intercept here. That is intercept that is equal to R. Shall we draw the graph now? Let us draw the graph like this. This is y-axis, this is x-axis. X-axis is nothing but R, the concentration of the reactant R, concentration of reactant R. And the y-axis is time t. Right? What happened that intercept is nothing but R naught. This is the intercept, right? Intercept is nothing but initial concentration R naught. Now, what is the slope here? Negative slope. So, being the concentration decreases with respect to time. Am I right? In a reaction, reactant gives a product. What happens to the concentration with respect to time? The concentration decreases. So that this is a concentration here. With respect to time, the concentration decreases. Right? What is the slope here? Slope. So we get found out here the slope is minus k. So this is a graphical structure for a zero order reaction. Got it? This is a graphical structure for a zero order reaction.